Hello friends, welcome back to my YouTube channel. In this class, I am going to discuss about equivalence of two statements of second law of thermodynamics, that is Kelvin-planck and Clausius statement of second law of thermodynamics. These two are negative statements of second law of thermodynamics. Negative statements are difficult to prove, and the second law of thermodynamics can only be established by experimental investigations, and up to date no experiment has denied the correctness of these two statements. So that's why these two statements can be considered to be valid statements. And these two statements are equivalent in their consequences, and either statement can be used as the expression of the second law of thermodynamics. And any device that violates the Kelvin-planck statement also violates the Clausius statement, and vice versa. So we can prove that if the violation of one statement leads to the violation of the another, then these two statements are equivalent in their consequences. That we will prove through this lecture. Before starting, I must say one thing to all of you. Please do subscribe to this channel. Of course, like it and share it to your friends. So let's consider. Let us consider there are two reservoirs. One is high temperature reservoir, which is at temperature TH, and another, this is reservoir is low temperature reservoir at temperature TL, and heat engine is working. This is suppose a heat engine is a clockwise cyclic device. Suppose this heat is absorbed by heat engine from this high temperature reservoir, and suppose no heat is rejected from this heat engine. That means it is violating Kelvin-planck statement. So net work will be, this is the W net. Net work will be equal to QS. Kelvin-planck statement states that a heat engine to produce net work in a complete cycle has to exchange heat with two energy reservoirs, thermal energy reservoirs. But in this case, you see, net work output is produced, but the heat engine exchanges heat with only one reservoir. That means it violates Kelvin-planck statement. Suppose another refrigerator is anti-clockwise device, which also operates in a cycle. So suppose it absorbs heat QL from low temperature body, and this is the heat released to the high temperature body, that is at a high temperature reservoir, that is at a temperature TH. So according to energy balance, this heat will be equal to, suppose this is QH dash is equal to QH plus QL, क्योंकि summation of energy transfer across system boundary during a cyclic process is zero. Whatever energy enters into the refrigerator during this cycle, that energy is QH plus QL. That energy should leave the refrigerator, because whatever energy enters to a system, closed system, during a cyclic process must leave it according to energy balance principle. So QH dash will be nothing but equal to QH plus QL. So if this combination of two systems can be viewed as a refrigerator, suppose viewed as another refrigerator, then what are the heat interactions for this refrigerator? This is low temperature reservoir, this is high temperature reservoir. So as far as the heat interaction from low temperature reservoir is concerned, only heat that leaves the low temperature reservoir is QL. So what is the net heat interaction to this high temperature reservoir? Here heat that enters into, that is QH dash minus QH, क्योंकि हम यहाँ net heat that enters or that is absorbed by this source or high temperature reservoir is to be calculated, because the arrow sign is towards the reservoir. So QH dash is the heat that is absorbed by the refrigerator, but QH is the heat rejected by the refrigerator. So net heat absorbed by the refrigerator will be QH dash minus QH. From this you see QH dash minus QH will be QL. That means this heat is also equal to QL, and so that there is no net work input, दिस इज जीरो, क्योंकि ये तो QL है, ये भी QL है. सो इसका मतलब नेटवर्क आउटपुट, नेटवर्क इनपुट इज जीरो. बट दिस इज ए वायोलेशन ऑफ क्लॉसियस स्टेटमेंट ऑफ सेकेंड लॉ ऑफ थर्मोडायनामिक्स, क्योंकि क्लॉसियस स्टेटमेंट स्टेट्स दैट for heat transfer from low temperature to high temperature body, there must be some effect on the surroundings, there must be some trace on the surroundings, some network input has to be made, but here the network input is zero. That means this refrigerator, this equivalent refrigerator violates Clausius statement of second law of thermodynamics. So what we proved is violation of, here the violation of Kelvin-planck was there, and that results in violation of Clausius statement. So violation of Kelvin-planck results in violation of Clausius statement. In another example, we will prove that violation of Clausius also leads to the violation of Kelvin-planck. So then the equivalence should be proved. So suppose this is a high temperature reservoir, which is at temperature TH. This is low temperature reservoir at TL. Suppose there is a heat pump which is anti-cyclic device, anti-clockwise device, heat pump which works in a cycle. Let the heat absorbed by heat pump from low temperature is Q1, and the network is zero, network input is zero, and it rejects the same heat to the high temperature reservoir. That means the heat pump works in violation of Clausius statement of second law of thermodynamics. Because you know Clausius statement states that for devices like refrigerator and the heat pump to operate and to transfer heat from low temperature to high temperature reservoirs, some networking input has to be made and to leave a trace on surroundings. So in this case network input is zero. So same heat is, whatever heat is absorbed from the low temperature reservoir is released to the high temperature reservoir. So network input is zero. That means this heat pump is a violation of Clausius statement of second law of thermodynamics. If suppose another heat engine also works between same two reservoirs, heat engine, and it works in such a rate that this heat engine works in such a manner that the heat absorbed by this heat engine from the same temperature reservoir, hot temperature reservoir, TH, is equal to the heat released by heat pump to this high temperature reservoir. That means whatever heat is discharged by heat pump is fed to the heat engine. That means thus the necessity of this high temperature reservoir is eliminated, because the whatever heat is discharged by heat pump is fed to the heat engine. Whatever amount of heat the heat pump discharges, that goes to the heat engine as heat input. Then suppose network output is produced. Suppose some network output is produced, and this heat released to the low temperature reservoir is Q2. So network output, here heat engine produces network output is Q1 minus Q. If we consider an equivalent heat engine of this combination of devices, combination of systems is a heat engine, suppose working between the same temperature reservoirs, same temperature limits. Suppose this is the equivalent heat engine, works between the same temperature reservoirs TH and TL. Then what are the heat interactions for this heat engine? You see, as far as the heat interaction from the high temperature reservoir is concerned, same Q1 heat enters into it and Q1 heat leaves, Q1 amount of heat leaves the reservoir. That means zero heat interaction with the TH reservoir, high temperature reservoir. And network is Q1 minus Q2. And here you see the heat interaction or heat supply, heat that is given to the low temperature reservoir, heat supplied to the low temperature reservoir is Q2, because this heat is supplied to it, and out of that Q1 is emitted from it. That means net heat supplied to the low temperature reservoir is Q2 minus Q1. So 0 minus Q2 minus Q1 is your Q1 minus Q2 network output. But this is an impossible device, and this is in sharp violation of the Kelvin-Planck statement of second law of thermodynamics, because Kelvin-Planck statement says that for heat engine to produce net work in a complete cycle, it has to exchange heat with two thermal energy reservoirs. But in this case, heat engine produces some net work by exchanging heat with only one reservoir, that is low temperature reservoir TL. Since the heat interaction heat exchange of heat is zero here with the higher temperature reservoir, that means heat engine is producing net work output with by exchanging heat with only one reservoir, which is a violation of Kelvin-Planck statement of second law of thermodynamics. So it is proved that violation of Clausius statement results in violation of Kelvin-Planck statement. A device which violates Kelvin-Planck statement also violates the Clausius, and a device which violates Clausius statement also violates the Kelvin-Planck statement of second law of thermodynamics, and either one can be expressed as a statement of second law of thermodynamics. And it is proved that both these two statements have equivalent consequences. So thanks for watching.